Okay, so in this example, we're looking at the value of a car by age. And if you look at the graph, what's happening as the car gets older, as the age increases? What's happening to the value of the car? It's decreasing. Okay, that's what happens with cars. Depreciate. Okay? When you say something's depreciating, it means it's losing its value over time. Cars depreciate. So the graph shows its value over the first 3 years, okay? We're going to figure out when his car will be worth nothing after how many years. We'll get to that, but we're going to go through each of these questions. So for A, I want you to calculate the amount by which his car decreased in value between year 1 and year 2. So from here, from B to C, how much does it decrease in value? From year 1 to year 2, we're calculating how much it dropped in value. So $22,675, take away the value that it was in year 2, and it decreased by $4,825. Next question is asking us to calculate the rate of change between year 1 and 3. What does rate of change mean? Rate of change, this is important, it's a change in one variable relative, that means in relation, like relative to the change in the other variable. So what are the two variables here that we're comparing? Exactly, so we're comparing value over time, right? The value of the car, which is our y variable because it's on the y-axis, and the age in years, so time in years. So we need to figure out at what rate is it changing? Well, from year 1 to 3, what's the rate at year 3? Not rate, what was the value? Sorry, what's the value of the car at the third year? How much? And what's the value of the car at year 1? $27,500 for year 1, wasn't it? 22,000 and what is it? 675, sorry. Okay? That's the value, how it's changing. What am I going to do with these two values? Subtract. Okay, we're going to subtract the values and the years that it's changing from year 3 to year 1, right? Okay, so this value, subtract that value, is 9,650. 3 take away 1 is 2. Can we simplify this? This is a negative, by the way, right? Yeah. So a negative divided by a positive is negative. What's the answer? Okay, negative 4,825. That's the rate at which this car is decreasing in value. Why is it a negative?
Because it's decreasing.
The value is decreasing. The rate at which it's changing is by a negative amount because it keeps losing money every year. So the rate is actually negative 4,825 per year, right? Okay, so for question C, we're going to do the same thing, but with year 1 and 2. What's the value at year 2? 17,850, and year 1, 22,675. Year 2, take away year 1. What is the rate from year 1 to 2? We get negative 4,825. What do you notice from the other question?
Decreased it by negative 4,000.
It's the same answer, right? This is referred to as the slope of the line. Okay, we'll talk about that now. Slope, if you're looking at the line, okay, rate of change, we're referring to the context of the question. Slope represents the exact same thing. It's telling you the steepness. The steepness of the line, right? How much it's increasing by or how much it's decreasing by. Actually looking at the rise of the line. This is the rise, how much it's rising by. It can be a negative over the run. So you're looking at the difference in your y values over the difference in your x values, the vertical distance and the horizontal distance. Okay, to find the differences, we're going to skip the first one. You're finding the differences in the y values, okay? Remember, this was your x and this is your y. So you're going to subtract the bottom number from the top number. So the first one is going to be 22,675, take away 27,500, and I want you to write down what that's equal to. Then you're going to do it for the second one. This, take away this, And the last one, this, take away this. I want you to calculate all the first differences. So we get negative 4,825. The next one is also negative 4,825, and the last one should be the exact same. How do the first differences compare to the slope? Were they different? No, they're the same. So we can conclude that the first differences are equal to the slope, which is also equal to the, what? What was the other word we used? Rate of change, okay? All of these represent the exact same thing. For part E, it's asking you to complete the following table. What do you notice about the age of the car in part E, which is different from the age in the car in part 1? So, in this example, it was going up by 1. Well, if I divide this by 1, does the answer change? Divide by 1, divide by 1. It's still the same answer, right? To find the differences for this one, well, the rate is not for every year, it's for every 2 years. So how am I going to find the rate per year? Yep, divide by 2, okay? So 17,850, take away, divided by 2. What's the rate? Is it going to be something different? 9,000. Okay, so this time the differences are negative 9,650. Why were they different? Because the age of car is every 2 years. So if we fill in the missing value, for the value of the car after 4 years, what's it going to decrease by? Okay, so after 2 years, this is the value. Another 2 years after that, I got to subtract 9,650. So we have a value of 8,200. That's at the 4th year. We're going to write an equation that looks at the value of the car. So you can call this V if you want. And the age of the car. Choose a variable. Sure, A. I want you to come up with an equation that represents this situation. Okay, well, we know it's going to be, we're trying to calculate what the value of the car is equal to. So think about what it starts at, what the value it is to start, and how it changes every year. Because this is the initial value of the car, and then every year, so per year, it decreases by $4,825. Which part of this equation represents the y-intercept? Yes, this. This was the y-intercept. This is where the graph started. And what does this represent?
X. First difference is the slope.
Yeah, slope. Okay? And we also know it's a partial relationship because it has a constant term. And it does not start at the origin. This didn't start at 0, 0. Okay, for the next question, we want to know the x-intercept. We want to know when the line hits the x-axis. When it hits the x-axis, what is the value of the car? Nothing. Remember the initial question says, calculate how many years it will take to earn nothing. So you can do this a couple of ways. You can use the table. What was the last value we found? At year 4, how much was the car worth? Okay. Can you calculate how much it's worth at year 5 and how much it's worth at year 6 and 7 and so on, and keep going until you hit 0? When it gets to year 6, what happens to the value of the car? Yeah, it's negative, which means they're going to have to pay into it. They're losing money on the car, basically.
But how do you do
So,
still running?
when would his car be worth nothing? Between how many years? Between 5 and 6 years. Good. I talked about this. First differences and slope are the same. When, what? We use intervals of 1. Remember when we used an interval of 2, it was a little different? So when using intervals of 1, it does not matter which points you choose. Okay, if you think about it, if I have a straight line, the difference from here to here will be the difference from here to here. It's a straight line. It's decreasing by the exact same amount every single time, okay? And Cody just used a word. We'll talk about this. This is a linear
Yeah.
relation. It's a straight line. Why are first differences constant? Why were the first differences the same? Because it's decreasing by the same amount every single time. And you can see that from the graph because it's a straight line.
Made with Doodlecast Pro.